and as you know, we are discussing about the circle diagram of three-phase induction motor. Circle diagram approach of analyzing a three-phase induction motor performance is very popular. That is, you do not have to calculate anything. Once for all, you just have the circle diagram for that motor drawn, then you can estimate mind you, whether it is very exact or not. There are so many approximations. We bring the parallel branch in forward and things like that, but a very reasonable estimate of the performance of the three-phase induction motor can be then very easily done. And last time we showed you that the circle diagram of the motor will be somewhat like this. This is the no load current, two branches are there parallel, and one is that side of the parameter where all the series parameters are added up, and the circle diagram was like this. Circle diagram was like this. Then as usual, and this is your voltage V 1. Similarly, here is also, if you draw a line parallel to this also is V 1. So, this current is that I 2 dashed reflected current, and at S equal to 1 it was like this. There were two points, operating point we considered. One is at S equal to S, which means at standstill condition, and another is the actual operating point, which could be lying here P. Okay. Remember, in the RL circuit circle diagram, when R changes, I told you this is R equal to infinity and this is R equal to 0, but here R will vary from the inherent resistance, which is at this point, R increasing this way, no doubt that is correct, and up to the full load point. That is, a segment of this whole circle will be of interest. Anyway, we will come to this slightly later. So, this is the thing, this is a standstill condition, this is at any slip S. Then what I told that just recollecting very quickly, this length, vertical length, if you drop a perpendicular here, this length in some other scale will represent the constant losses of the induction motor, and this will be at S equal to 1 the total air gap power, not total air gap power. If you divide this segment in the ratio of R 1 is to R 2 dashed, in this ratio if you divide this line R 1 is to R 2 dashed, then if you draw a line passing through this point, then this length will represent the stator copper loss at standstill condition, and remaining power is the air gap power. At standstill condition, of course, that total air gap power will be lost as rotor copper loss. Okay. And then at any slip S when it operates, if you drop a perpendicular, once again the total input power is given by this length, of which this length will be that constant losses, this length will give you stator copper loss, this length segment will give you rotor copper loss, and the remaining power is the mechanical power output of the machine. So, this to this length, that is say if I name them as I named previously P, G, K, okay, P, G, K, and this point is suppose N, and here I named it like this S, L, M, S, L, M. So, at any slip at any slip, mind you, Pg is the mechanical power output. The length Gk is rotor copper loss, and length Kn is stator copper loss. And Pn is the power inputted into this series part of the circuit. This is R1, this is X1 and this is X2 dash, this is R2 dash. So, Pn is the power in this branch of this circuit, Pk or Pk, I will write it like this, Pk is the power here, this length, not this length, after this. After stator resistance loss, this is the power, and therefore, Pk is the air gap power. Okay. Then it is fairly complete. Only thing I have to tell you how to draw the circle diagram, that I will do, but before that, for completeness sake, another interest, because how to fix up the operating point. Maybe I will be telling that the motor is operating at 5% sleep. Then corresponding to that 5% sleep, I have to fix up this point P, and for that also you have to calculate then something where it should be. You may be asking what are the parameter values, but another interesting thing can be done, that is called slip line. And that I just indicated in my last lecture at the last moment, that you can draw a slip line in this way. What you do is this, you take any point on this axis, let this point be called R. And also note that I called this to be my torque line. Why torque line? Because this power, air gap power, is a measure of torque. Gk is rotor copper loss. So, Pk is air gap power. Therefore, this is the torque line, and that is the air gap power, this intercept. Pk gives you a measure of the torque, because air gap power in synchronous watt gives you torque, divided by 2 pi ns you get the torque. Okay. And this Pg is the mechanical power output, this length. Therefore, the intercept between this and this is called the output line. This is called the output line. Is that clear? Now, what you do, you take any point R on this V1 axis. You could select it here, but it will become very clumsy. So, take it above and draw a line parallel to this torque line. Okay. Draw a line parallel to this torque line. So, this line is parallel to torque line. Draw a line, that is this line parallel to this, and then you extend this lens, this one and this one. So, it will intersects at these 2 points. This point I called T and this point I called Q, suppose this point of intersection Q. Okay. And then it can be shown, or I will show that this length R t will be a measure of the slip at which the machine is operating. How this can be shown? Once again by considering some similar triangles and call this is as O, this is suppose O dashed. So, consider 2 similar triangles, triangle O R T, that is this triangle, and the triangle O P G. Triangle ORT and triangle OPG you consider. These 2 triangles OPG or OPK, sorry OPK, this triangle and this triangle, these 2 are similar. Why? Because this angle must be equal to this angle. This is parallel to the torque line, is not? And also this angle of this big triangle is equal to this angle, and the third angle this and this will be parallel. If that be the case, then from this I can write, you first take this big triangle, side opposite to this angle is R t divided by, this is R t divided by O k, is not? Big triangle I have taken first, then you take side opposite to this curved angle, that is O r divided by P k. In the same way, you take, now consider the triangle, big triangle corresponding to this line O R Q, and triangle O S O P K. So, O S, this point may be called G. So, O R Q is this big triangle and O S G. Oh, the L, say this point O L, I marked it. So, O S L. These 2 triangles are also similar. Why? Because O S L up to this I have taken. Na? So, this angle is equal to this angle. And also and also this angle will be equal to this angle. This and the third angle will be equal. So, once again I do the ratios. Therefore, first the big triangle, triangle ORQ, this angle you take, opposite to that is RQ, divided by, in this triangle it will be equal to OL. This point is LL. So, RQ by OL, and this will be equal to OR divided by SL, and we are done. I mean, if we write these two, because these two triangles are also, I mean, what is called similar triangles. Now, what you do, you divide this equation 1, this equation 2, divide 1 divided by 2 you do. If you do, it will be, left hand side will be RT by OK divided by OL will go up RQ, left hand side divided, and the right hand side will be OR by PK into SL by OR. So, OR cancels out and you will be left with RT to be equal to SL by PK, it was there, and all other terms from this side I will take it to the right hand side. So, it will become equal to OK by OL and whole thing into RQ. This will be the thing. Now, what is SL by PK? Is not? Is that clear? SL by PK is how much? SL is the, and OK by OL. Acha, OK by OL. Acha, this you can write it like this. So, this is equal to SL by PK, and then OK by OL, this length by this length will be same as, because these triangles are also parallel. So, that is this triangle and this whole triangle is parallel. So, OK by OL will be same as GK by SL, GK by SL, because these two are parallel. So, this OK by OL will be also equal to GK by SL, and then SL goes and you are left with into, of course, RQ is there, and this is equal to GK by PK into the length RQ. But what is GK by PK? PK is air gap power and GK is the rotor copper loss, which must be equal to S into PK. Therefore, what happens is this, you get RT is equal to S into RQ. This is the thing. So, here the trick is here, that is OK by OL is once again these are all parallel. So, OK by KL will be same as ON by OM, which is same as GK by SL. That I have applied and I get this. Therefore, the length at t, so finally what we have got at t is equal to g k by p k into r q, but g k by p k is slip, it has to be, because air gap power into slip, that is S into p k is equal to g k. G k is equal to S into p k. So, this will be S into r cube. Therefore, what I have done, you have taken a point, any point r, then we have drawn a line parallel to the torque line, this line. Then the point of intersections capital T, and this is O Q. So, R Q is this length. Suppose I call R Q, suppose I say that it is equivalent to slip equal to 1. This whole thing I will say slip equal to 1, this length represents. Then I immediately know R T will represent slip. So, the idea is you draw a line, take a pointer, draw a line, find out the point of intersections, then this R Q you call S equal to 1, because it goes there, arbitrarily call, okay, this length represents S equal to 1. If you do so, then R T must be the slip corresponding to this point. Here also it is slip corresponding to this point, because S equal to 1. Then what I will do is, I will break this up in equal segments, divide this line in 100 segments. So, each segment will represent 1 by 100 slip. Or you say, if somebody gives me a problem that at slip 0.04 I want to find out the performance, I have this slip line also drawn, divided. So, I will this much centimeter represents slip 1, then 0.4 represented by which centimeter, I will cut that length and join this point with this point, point of intersection will be the operating slip. And once I go to that operating point, I know everything, total input power, air gap power, mechanical output power, torque developed by the machine, and so on. So, this is called the slip line. So, for a motor, if you have this circle diagram drawn, then you can estimate the performance of the machine for any value of slip which is between 0 to 1 and get the performance. So, that is about slip line. Of course, slip line it is not necessary you always draw slip line, but it is better for completeness sake, and that is what a practical engineer can do. For the given induction motor he is working on, once for all draw this circle diagram, and then you can perform the prediction of the induction motor. So, slip line we have done. Now, let us just try to see. So, henceforth I will not draw this slip line to highlight many things. For example, I have got the circle diagram somehow, that somehow I will explain how to really get it. Now, this is your no load current, and this is this. So, this current is this current actually I naught, and then this circle diagram has been drawn, and then these 2 points are crucial, S equal to 1 point, standstill point. This is here, drop a line, and do not forget to divide this line in the ratio of R 1 is to R 2 dashed. Then draw another line, and then this is torque line. I am repeating, it is better so that you understand. This is output line. Now, either from the slip line or somehow if somebody says this is the operating point now, you simply join this. Current drawn from the supply will be then this length, this is suppose O dashed P will be the current drawn from the supply. What will be the power factor of the motor? Join this point. Cosine of this angle will be the power factor angle. What is the total input to the motor? Drop a perpendicular. This whole length will represent, in some scale of course, the total kilowatt input. What is this length? This length will be the constant losses. What will be this length? Stator copper loss. Per phase, if it is per phase you have drawn. What will be this length? Rotor copper loss. And what will be this length? From this to this, torque line. This also air gap power. So, air gap power is torque line divided by 2 pi ns to convert it to Newton meter, and this one will be the mechanical power output. So, this are named like this G in our earlier diagram also N, and let this be called some U. So, Pu is the total input. And you, as I was telling, efficiency of the machine will be output power, that is Pg, divided by Pu. And of course, I can find out also rotor copper loss, stator copper loss, input power factor and so on. Everything can be found out. Suppose somebody says that what will be the operating point corresponding to, mind you, sleep is decreasing this way. Sleep is highest at the starting point, then it is decreasing, going towards full load sleep, which is very small. Now, suppose somebody asks me that what should be the operating point corresponding to maximum torque the motor has produced, then what you have to do? Then you have to simply do this thing. Torque line is there, take a set square parallel to this torque line, wherever this is parallel to torque line is there, then only this interception will be maximum. It can be shown, I mean like that. So, this corresponds to maximum, this intercept will be maximum when the operating point through that, if you draw a line parallel to this, then only this segment is maximum. Similarly, if somebody says I want to get output power maximum. So, from this then I will calculate back this slip and tell okay, the machine is operating at this slip. Similarly, if somebody says what will be the operating point corresponding to maximum output power, then what you have to do is this, you have to draw a tangent to the circle, find out the tangent to the circle which will be parallel to the output line, because output power is after all this length, this segment. So, draw a line parallel to output line, wherever it will be cutting, it is parallel to output line, and then wherever it cuts, I say that is the operating point corresponding to maximum output power. If somebody says that what will be the operating point when the power factor at which the motor is operating is maximum, then what he has to do is this line he has to draw a tangent. I better draw it in a small version what I am trying to do. This if somebody says motor find out the slip or operating point such that the power factor at which the motor is operating is maximum, what he will simply do, the total current drawn from the supply is this, is not this dotted line. So, draw a tangent to this circle, this will be the operating point corresponding to maximum power factor. Because you can easily see for any other power factor, this angle which is the power factor angle theta, that will become more, and cos theta is the maximum value we will have only at this point. So, several things can be done if you have circle diagram drawn for a given machine. Now, the question is how to get this circle diagram drawn rather easily. The circle diagram can be drawn by doing these two simple tests. You do not have to find out the parameters exclusively to draw the circuit diagram, although it looks like okay, unless I do not know the parameters, how can I draw. But we will see now by doing two tests, one is called tests. I mean question is how to get the circle diagram, how to draw the circle diagram. The answer is do this test, do this test. One is called no load test, and the other is called blocked rotor test. Blocked, or some people call it, or locked, same thing, locked rotor test. And I will show you in the next class how from the readings of those tests circle diagram can be rather very easily drawn to scale. Thank you.